Good day class. In today's video, we will be understanding how to control the reactive power output of a generator. The learning outcomes for this video are as follows. We will first be understanding the significance of the reactive power output of the generator and then understand what is meant by reactive power exchange. Finally, we will be learning how to control the reactive power output of the generator. The reactive power Q supplied by a generator is equal to 3VE by X cos delta minus 3V square by X. Here, reactive power control is done by adjusting E. Although the power angle also affects the reactive power output, the internal voltage magnitude dominates the final output. Let us rewrite this equation as follows. We write Q as 3V by X into E cos delta minus V. And let us consider the following three cases for reactive power output. Firstly, if E cos delta is equal to the terminal voltage, then this term becomes 0 and there is no reactive power exchange between the generator and the grid. The next case is if E cos delta is less than the terminal voltage, then the reactive power output is negative or the generator is absorbing reactive power. This operation mode is called the under-excited operation mode. And finally, if E cos delta is greater than V, the reactive power output Q is greater than 0. The generator is supplying reactive power to the grid. This mode is called the overexcited mode for the generator. Let us try to understand the reactive power exchange under different load conditions. We can vary the magnitude of the excitation voltage to either supply or absorb variable amount of reactive power. If the load is lagging in nature, then E cos delta is greater than the terminal voltage V and the generator is supplying reactive power to the load. Thus, the generator is overexcited in this case. If the load is a unity power factor load or purely resistive, then there is no need for the generator to supply any reactive power and E cos delta is equal to the terminal voltage. And finally, if the load is leading in nature, then the load supplies the reactive power which is absorbed by the generator. Here E cos delta is less than the terminal voltage and thus the generator is under-excited. How do we adjust the excitation voltage E of the generator? The magnetic field can be intensified with higher field current magnitude, as a result of which the excitation voltage of a generator will be increased when we increase the magnitude of the magnetic field. The magnetic field will still rotate at the same frequency, but it will rotate with a higher magnitude. We can sum up the reactive power output of a generator as follows. When we increase field current, the magnetic field is intensified. As a result, the internal excitation voltage is increased and thus the reactive power output is increased. There are two operating conditions of a generator. When the generator is supplying reactive power, it is called to be in overexcited mode, and when it is absorbing reactive power, it is called to be in underexcited mode. Let's see how to control the reactive power output of a generator. Here, the terminal voltage V and the power angle delta remain unchanged. The current magnitude and the angle theta, which is corresponding to the power factor, will change as a result of the change in excitation voltage magnitude. If we want to keep the power factor constant, then we can adjust the excitation voltage to maintain the power factor of the original load. Let's draw the phasors for the control of reactive power in generator. The assumption is that the power angle and V remain unchanged. Let's say we originally have some load reactive power requirement which gives us a current I and power factor cos theta. Since delta is constant, it is going to be constant along the dotted lines. Now, if the reactive power requirement is increased, the excitation voltage is increased, the current should also change along with the power factor when we keep the power angle constant. In summary, we understood the reactive power output of a generator in the different operating modes of the generator, namely the under-excited and over-excited modes. And finally, looked at the control of reactive power output of generator by changing the excitation voltage of the generator. Thank you.